You know what I've noticed about this Internet of Things that's taking over the world? The things are mostly just sensors, and we've got bazillions of them. Wait, no, I know bazillion isn't a real word. It was just, a hyperbole. It was a. No? Okay. We've got huge boatloads of sensors out there. Oh, still not okay? All right. Experts estimate that there will be as many as 1 trillion sensors connected to the IoT during this decade. Is that better? Yeah? All right. Man, this is a tough room. Anyway, the topic I was trying to get across was what about these sensors? They're changing and evolving constantly, and there are huge technology and market trends driving them. Besides the fact that there are a whole bunch of them probably joining social media groups on the IoT. And what are they really up to? Hi, I'm Amelia Dalton, host of Chalk Talk. Today I am talking with Pete Smith from TE Connectivity about the trends in sensor technology. And I've got bazillions of questions for him. Let's go. And before we get started, don't forget to click that link. There you can find even more information about TE Connectivity's sensor solutions. Hi, Pete. Thank you so much for joining me.
Well, we appreciate you coming to us and talking about our products. Thank you.
Okay, so Pete, it seems like how we design sensors is changing daily these days. What kind of trends are you seeing in this space?
Amelia, we are seeing a number of trends, and they're primarily driven by our customers. They're coming to us and telling us about the products they're developing and the sensor needs that will be used in those products. We're seeing 5 major trends right now that are helping us define and drive new sensor product designs. They're miniaturization, digitization, low power sensors, multi-sensor modules, and sensors for harsh environments.
Sure, okay. So, Pete, let's start with that first one on your list, miniaturization.
Most of our customers are designing consumer products, which is a good example. And what they're doing is from their customers, there's a drive to get the devices smaller. Smaller space, lower weight.
Sure.
There's a never-ending push in that direction. And so our customers are finding that they need to pack more and more capabilities into the products because at the same time, the customers are asking for more and more features and capability in the product. A cell phone is a good example.
Sure.
Where they're trying to make them smaller, but they're trying to put more features and capability into them. And so that affects the way that the sensors are designed for those kind of applications. And we undergo the same pressure from the manufacturers to make our sensors smaller.
Sure.
And to put more capabilities into them. And we do it in several ways. In this particular slide, you can see an old design is where we put elements in the sensor are side by side on the printed circuit board. And they're all interconnected to provide the function that the sensor is supposed to create. We take those elements now, which are the microprocessor, the sensing element, and some passive components, and now we're stacking them on top of each other to get a smaller footprint on the board. In this particular case, we're taking a product that has a 4 millimeter by 4 millimeter footprint, and we're shrinking it to 3.3 by 3.3 millimeters. Now that doesn't sound like a lot of space savings. It's 7/10 of a millimeter, which is about 30 thousandths of an inch, which is about 3 or 4 hair widths wide.
Yeah.
But in talking to our customers, if you can give them 7/10 of a millimeter of extra space, it's a really big deal for them.
Absolutely.
And so these kinds of developments and design ideas are being incorporated across our sensor products to give them a smaller device with a lot more capability.
Okay, so Pete, what kind of applications are you seeing specific to this trend of miniaturization?
I'll talk about a couple here, a couple of typical applications that we see. We do supply sensors to the sport watch industry and the fitness watch industry. The advantages are these sensors can fit into the small packages. If anybody has a fitness watch on their wrist right now, you can look at it and you can see it's fairly small, it's light, and there's a lot of stuff in there, a lot of capabilities. And our sensor is part of many fitness watches out there. We're monitoring the barometric pressure, and the primary reason for the barometric pressure sensor in them is we're looking at altitude. If you have a fitness watch on and you're hiking up a hill, you're using more calories than if you would hike on level ground. And we monitor the change in altitude, and that gets figured into the calculation for the calories. If you're hiking down the hill, which is my favorite, we burn less calories. And so they factor that in, and the fitness watch catches you if you're cheating on the calorie count. And it's a very sophisticated sensor in it, not only, and we'll talk about this a little bit later, but it's also a digital sensor. And so it provides the data in digital format, which is easy for the fitness watch to use in their microcontroller. Another application we find our watches is in the e-cigarette industry. We do make an altimeter also that goes into those, but its purpose isn't to monitor the barometric pressure or the altitude. It's primarily a sensor to detect when the user is actually inhaling from the device. When you inhale through the device, it pulls a vacuum, which is a lower barometric pressure. And it turns on, when it senses a vacuum, it turns on the misting feature in it that actually creates the atomized smoke and whatever they do. And so when they stop inhaling, it actually turns it off, so there's no waste. It maximizes the use of the little oil pods, and you don't atomize material just into space. It doesn't get inhaled. So in that case, it's also important because small size and capabilities and digital products too. So those are two good examples of making these products smaller.
Okay, so Pete, let's move down the list one more and talk about digitization. Now, for decades, we've been dealing with analog in this space, but that's changing pretty rapidly, right?
Amelia, yes, it is. We, for years, made our products all had analog output, and that was because our customers expected it. They were used to it. They knew how to deal with it.
Right.
About 25 years ago, the world started moving into the digital world with products, digitizing all kinds of consumer products, industrial products, commercial products. And to get the sensors to talk to the systems, they began asking us for digital capabilities. And so what we've done is put that into our sensor products. Virtually all of the sensor products we introduce today are available in both analog and digital output. The common digital protocols that we see are I2C or SPI. These are kind of de facto standards globally for digital interface. And so every one of our products we introduce now have those capabilities. Some other advantages when we digitize our sensors is we get better performance in terms of resolution and accuracy. And digital sensors draw less power, and we'll talk about the power issues in a few minutes here. And the digital sensors are much more compatible with IoT type applications.
Sure. So, Pete, what kind of examples are you seeing here?
We see digitization across many industries. Here's just a couple of examples. Pneumatic control systems for factories, where you are trying to control air pressure and monitor various air systems that might be used for the machinery in a factory. We have sensors that can handle both low pressure and high pressure systems, and they're available in a variety of references. And if you're familiar with pressure sensors, they come in gauge, differential, and compound ranges.
Yeah.
We provide all those kind of products, but we also offer it. If we do have some customers that still prefer analog, but many are going digital now for IoT and industrial IoT applications. So the ability to fit into those kind of systems, the digital products make it much easier. HVAC control systems too, where you were looking at humidity, the temperature, the airflow rate through the ductwork. Mm-hmm. All those now are going digital. All the systems that are out there are turning into digital systems, and so it makes it a lot easier to apply sensors in those kind of applications because we have the digital output.
Sure. So if we're talking about sensor applications, we're going to need to talk about that elephant in the room, power, right?
Yes. We're going to turn it into a mouse if we can.
Good.
One thing that we're seeing, particularly in consumer space, is most of our customers are moving to battery-powered types of products.
Sure.
And when you talk to an engineer that's designing a battery-powered product, he has three things on his list: priorities, and that's battery life, and battery life.
Sure.
Which are directly correlated to the amount of power every component in his product consumes. So he has a power budget, and he has to live within the power budget. And so there's constant pressure from our customers to deliver sensors that have lower and lower power consumption. And so we endeavor to, particularly in the digital space, provide sensors. Here's a few examples. We have our TSYSO2, which is a combination temperature and humidity sensor. The average current that it draws is 18 microamps, which is very, very low power, and it fits well into battery kinds of applications. We have our HTU21D, which is another humidity and temperature sensor. It draws 90 microamps of power. We have an altimeter, the MS5837, draws 20 microamps, and then we have an industrial pressure sensor, which draws only 180 microamps of power. And of course, finally, we have our altimeters that go into the fitness watches, 20 microamps of power. So we're helping contribute to longer battery life for most of our customers' products.
Sure. So, Pete, what areas are you seeing low power play a big role in?
We see it obviously in mobile devices. Every mobile device that people carry have batteries in them. And so the sensors that are used in there, again, to get longer battery life, or a longer time between charges, which is always desirable. You know, people get home at night and they throw their phone on the charger, and sometimes they forget, and the battery's dead in the morning, and you're all upset because you forgot. So any mobile device, phones, tracking devices, and navigation devices are battery powered and handheld, and we also see products that go into the outdoorsman world. For example, there's a pocket knife that's been being made right now that has an altimeter in it too. So when you're climbing the mountain, you can see how much altitude you're gaining as you're going up the hill. So it's interesting stuff. But they're all battery powered, and so they benefit from these low power devices. Home healthcare is another area. We do participate in the pendants that people wear. You've seen the ads on TV for the "Help, I've fallen and I can't get up."
Oh, yes.
The way those work is essentially when someone falls, it's a very rapid change in altitude.
Oh, right.
And when we see that rapid change with our sensor, it's only a 6-foot change in altitude, 5 or 6 feet, 4 to 5, 6 feet. We can detect that, and it triggers the system that says there's been a very quick reduction in altitude. Somebody fell down.
Wow.
And so that trips the device to call the doc or call the emergency services or however it's done. So these are the kind of applications. And obviously those are small, light devices. They're battery powered. And you want to make sure that the battery has a long life so that it always works.
Okay, so what if we need several sensors in the same application or even the same package? Now, a lot of IoT and edge applications are demanding this these days.
That's correct, and we are continuously getting inquiries from some of our customers and some of the people out there to put multi-sensor capabilities into single packages. The advantages are in space savings again.
Sure.
And in power savings, because you're powering several sensing elements from kind of a single power source.
Yeah.
Some examples of where we've combined sensing capabilities. We have our HTU21D. It's a relative humidity and temperature sensor. And what's kind of interesting about it, it's very small. It's only 3 millimeters square, very low power, as the things we've already talked about. But by taking the information from the sensor, we're actually measuring two things, relative humidity and temperature. In the software, if you take those pieces of data and do a quick calculation, you can also calculate the dew point.
Oh, okay.
And so with a single sensor that has sensing two parameters, we're able to supply 3 pieces of data to the customer.
Oh, right.
It makes it easier for the customer. It gives them the compact space. They don't have to put more than one sensor package in the product, and so it's a big help. We make another one, the MS8607, that's going into home appliances and in automotive applications. One good example is that sensor finds its way into a intake manifold on a car.
Oh, okay.
And we're monitoring relative humidity, the air temperature, and the barometric pressure, because all that information goes into the engine control unit in the vehicle. And they adjust the fuel that they put into the engine to make sure they get a nice clean burn. They don't waste fuel, and they don't produce carbon monoxide and nitrous oxides. They monitor all three of those things. It's a very small package that fits into the intake manifold so that it doesn't restrict the air, and it's very low power because cars have the same problem. All cars have batteries in them, whether they're electric or gasoline powered. The battery life is an issue in vehicles too.
Absolutely. So, what kind of examples can you show me in this area?
Again, we'll go back to our HVAC systems where we're putting multiple sensing capabilities into the duct in terms of temperature and relative humidity. Those are very popular parameters to monitor in air conditioning and heating systems because by monitoring them and controlling the system, you can create better efficiencies. We also see those used in medical. CPAP masks is a good example.
Okay, yeah.
Where the patient is breathing air in and out, and those machines that drive the CPAP masks have the capability to heat and cool the air and also humidify or dehumidify it in some cases. And it's what they're doing is making the air comfortable for the patient to breathe.
Ah, right.
If it's too dry, it's going to be uncomfortable. It'll cause dryness in your mouth and nose. If it's too wet, it's uncomfortable, and it makes your area of your face start to sweat in some cases. Right. Or if it's too warm or too cold. So again, we can put a single sensor in that and monitor the features that make that CPAP mask much more friendly to the patient.
Okay, so because of industrial IoT and IoT and medical IoT, Pete, we are seeing a lot of sensors placed in environments that aren't exactly friendly for sensors, right?
Amelia, that's absolutely true. You'd be surprised that I can't relate any specific stories, but we get customers who want to put sensors in places that they shouldn't go.
Yes, I'm sure.
And so how do we address that? One of the things that we try to do, and TE in particular is very proud of its capabilities here, is putting sensors in packaging that can withstand some of these very harsh environments. We have people asking us to put sensors underwater, for example. Or one example was the fitness watch that we showed earlier. We've designed that so that the sensor, because it's interested in looking at the atmospheric barometric pressure, it's open to the atmosphere. But what happens when somebody goes swimming with that watch, or goes and swims laps, or goes to the pool, or swims in the ocean? The chlorine in those particular environments can be very corrosive on electronic components. So we've developed sensors that can withstand exposure to chlorine in various ways. Also, a lot of sensors are finding their way into areas where there's very high EMI and RFI fields.
Sure.
So we put some special features around our sensors to protect from that kind of problem too. But essentially, you're right. There are a wide number of places, particularly with IoT, people are trying to put sensors everywhere.
Right.
They're trying to collect data. They're trying to listen to things that are going on so that they can optimize capabilities, optimize systems. And ultimately, as you said, they're putting sensors in places that are not real friendly. So we got to make the sensors able to withstand those kind of conditions, and that is pushing us in a lot of our package design right now.
Sure. So, Pete, what specific areas are you seeing this trend?
Well, as I mentioned, the fitness watch is a place where we make them chlorine resistant. We find applications where in industrial IoT applications where they're trying to put more sensors in a factory. And in factories, there are areas that are high temperature or very low temperature, and the sensors aren't designed to withstand those kind of temperatures, and so we put extra packaging around them to protect the sensors. In a pharmaceutical facility that's manufacturing pharmaceuticals, they have a lot of very strange chemicals that the sensors get exposed to. So again, we have to put packaging around them to protect. We use special materials, special polymers. Sometimes we have to make our sensors out of titanium or Hastelloy or Inconel, things that can survive very, very tough, corrosive, harsh kind of chemistry. And we pride ourselves in our ability to do that. One of our catchphrases is we do make sensors for harsh environments, and they're designed to withstand the tough world out there. So.
Excellent. All right, Pete, this has been a lot to take in today. Can you wrap up your main points for me?
Sure. There's been a lot of interesting developments in the sensor world. I don't know if most people know this, and they may not have heard of TE as a supplier for sensors, but sensors are everywhere. We're not one of those companies you may have heard of in everyday conversation, but our products are truly everywhere. We serve oil and gas industry, we serve medical, we serve aerospace, we serve consumer, commercial products, industrial products. And universally, we're seeing the same drivers from all of those industries in terms of the miniaturization that we talked about, digitization, low power capabilities, multi-sensors in a single package, and of course the harsh environment issues. And so to be a good player in that business, we obviously, like everyone else, we respond to our customers' needs, and we put a lot of effort into coming up with solutions that address those particular trends. So it's very exciting. Sensors is a very, very large growth area. I think people recognize it, and we actually are very happy to participate in it. And it's nice to be in a very strong growth environment with our products, and we feel like we're coming up with a lot of good things to help our customers.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Pete.
Well, Amelia, appreciate it. We're happy to provide the time, and if there's any questions from people, don't hesitate to call us.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from TE Connectivity. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube. Keyword EE Journal.